Hello, grade 10. So today we are continuing our study of quadratics, and we are looking at another form of a quadratic relation. So we've already looked at vertex form, which is a nice little form because it shows us the vertex. But we are moving on to what we call factored form. So quadratic relations, when they're in this form, so for example, y equals 2 bracket x plus 1, x minus 3. This is called factored form. Okay, so this is quadratic because notice that when we expand this, the degree is 2. So when we expand this, we would get an x times an x, okay, since it's bracket, and that would give us an x squared. So the degree is 2, and it is therefore quadratic. And what's cool about this equation, this form, is that it shows us what the zeros are, or what the x-intercepts are. So notice that it's of the form minus r and minus s, and that the x-intercepts are r and s. So that means in this case, the x-intercepts would be, so r would be -1, and s would be 3. So the x-intercepts here would be -1 and +3. And notice that there's a 2 there, which means it opens up. So it would look something like that. Okay, so those are the x-intercepts. All right, now I want to talk about why this is true, and this is very important and could come up as a communication question at some point along the way about why this is true. Well, the x-intercepts occur when we set the parabola equal to 0. Okay, so if you have, so let's say in our example, 2 bracket x plus 1, x minus 3 equals 0. Okay, so that's when the x-intercepts occur when y is equal to 0. Well, let's think about this. We have 2 times a number equaling 0. The only way for numbers to multiply together to equal 0 is if one of those numbers are 0. So if the product is 0, one of the factors, one of the numbers multiplied together has to be 0. That's the only way to multiply to 0. So that means either 2 has to be equal to 0, which doesn't make sense, or x plus 1 has to be equal to 0. So you get 2 times 0 times whatever, or x minus 3 has to be equal to 0. And then you get 2 times a number times 0. So for x plus 1 to be equal to 0, x has to be -1. For x minus 3 to be equal to 0, x has to be 3. So if you put the number -1 into this equation, you get it to be 0. Or if you put the number 3 into this equation, you get the whole product to be 0. So if you're generalizing this, so any number a times x minus r times x minus s equals 0. Again, the only way for the product to be 0 is if x minus r is equal to 0, in which case x is equal to r, or for x minus s to be equal to 0, in which case x is equal to s. So that is how we figure out the x-intercepts from a factored form. Now, we can also use this to find the vertex, okay? So the vertex, remember, is on the axis of symmetry, and the axis of symmetry is just halfway between the zeros. So if we have, again, our parabola, so let's just call this any r, and let's call this any s. So this is the coordinate s0, and this is the coordinate r0. The vertex is going to be halfway between them on the axis of symmetry. So remember, the axis of symmetry is halfway between the zeros because it cuts it in half. So the x value of our vertex is just r plus s divided by 2, the halfway point between the two x-intercepts. So again, x is equal to r plus s divided by 2. So in order to find the y-coordinate of the equation, we just take whatever x is, put it back into the equation, and find out what y is. Okay, so let's go ahead and do an example so this can be a bit clearer to you. So we're going to describe this graph, find the x-intercepts, the vertex, the axis of symmetry, then it's the y-intercept and its symmetrical partner. So the x-intercepts, we'll find them first because this is in factored form, so the x-intercepts. So we take our equation 2 bracket x plus 1 bracket x minus 7 and set it equal to 0. So again, either x plus 1 has to be equal to 0 or x minus 7 has to be equal to 0. So x is equal to -1 and x is equal to 7. So those are the two x-intercepts. So this is the coordinate -1, 0, and this is the coordinate 7, 0. So we can plot them. Okay, so now we need to let's find the axis of symmetry next. So that is halfway between our two zeros. So -1 plus 7 divided by 2 is 6 divided by 2, so 3. So x equals 3 is the axis of symmetry. So I'll use another color to show that here. And I'm sure you are using a ruler right now. Okay, so now let's go ahead and find the vertex. So we know that the x value of the vertex is 3, and we need to find the y value. So again, we take this 3 and we put it into the equation. So y equals 2 bracket 3 plus 1 bracket 3 minus 7. So this is 2 times 4 times -4. So we get -32. So our vertex is 3, -32. So in order to show this properly, I'm going to set my scale here that I'm going down by 5s. So this is -5, -10, -20, and -30. So my vertex is about there, and I'm going to label it 3, -32. Okay, now we need to find the y-intercept. Okay, so the y-intercept occurs when x is equal to 0. So then y would be equal to 2 times 0 plus 1 times 0 minus 7. So that's just 2 times 1 times -7. So that's equal to -14. So 0, -14 is our y-intercept, and that looks about right. So that's about right here. Now, we can use symmetry to find its symmetrical partner. Okay, this is 3 units away from the axis of symmetry, so we find another point 3 units in the other direction. So that coordinate would be 6, -14, while that coordinate is 0, -14. So now we can create our parabola. I'm going to go from the vertex up just so I draw a smoother curve. Sometimes this is easier than trying to draw, just from the left to the right. And then we can label it with our equation. Okay, so now we've done that one. All right, so let's go on to example 2. graph this. Okay, so I do invite you, if you're, a bit more advanced, to pause the video and see if you can do this on your own, or and then just verify it with me. So the x-intercept, so we're going to do that first. I'm going to go through this a bit more quickly this time. So I take my equation and I set it equal to 0 in order to find the x-intercepts. So again, either x plus 4 equals 0, so x equals -4, or x minus 6 equals 0, so x equals 6. So we can plot those points. Okay, so now we are going to find the vertex and the axis of symmetry. So the axis of symmetry is halfway between, so x equals -4 plus 6 divided by 2, which is 1. 2 divided by 2 is 1. Okay, so the vertex then has an x value of 1. We need to find the y value. So y equals -0.5 times 1 plus 4 times 1 minus 6. So if you do that, you get 12.5. So 12.5 is my vertex. So I'm going to make this go up by 2. So 2, 4, 6, 8, 10, 12. So if I go over 1 and then I go up to 12.5. Okay, now it should make sense to you why this vertex is up here, because we have a negative a value, which means it's facing down. So that should help with your understanding. Okay, so now we find the y-intercept by setting x equal to 0. So you get y equals -0.5 times 0 plus 4 times 0 minus 6. So that's just -0.5 times 4, which is negative, let me do this in my head. So -0.5 times 4 is -2 times -6, which is +12. So I'm actually right there for my y-intercept. And so that means I have a symmetrical partner right there, 1 to the other side. Okay, so I can draw my parabola like this. Oops. Sorry, I just realized I made a mistake there. So wait, 1. Oh, 1, 2, 3, 4, 5. Okay, 1, 2, 3. You probably think I'm crazy. I'm just making sure this was symmetrical because I just made it didn't look quite right, but it is. Okay, sometimes I need to check. Okay, and then you label it with the equation. All right, last example, we are going to actually come up with the equation if we're given information. So we have 2 different questions here, A and B. So in A, we're given the picture, the graph of the parabola, and in B, we're just given information about the parabola. And either way, we want to come up with the equation in factored form. So the first thing we're going to do is identify the x-intercepts. So this one has an x-intercept of 1, 0, and -3, 0. Okay, so we put it in. So our r is equal to -3, and our s is equal to 1, and we're putting that into y equals a x minus r, x minus s. So we have y equals a x minus -3, x minus 1, which gives us a x plus 3, x minus 1. Now you can skip that first step. I'm just showing why this becomes a plus 3 because we're subtracting a negative. So now we need to sub in a point so that we can solve for a. So you can sub in any other point that you know for sure is on the parabola. I subbed in the point -1, -8, which is the vertex, but you could have also subbed in this y-intercept. In fact, any point on the parabola is fair game as long as it's not one of the x-intercepts. Any other coordinate is fine. So I'm going to put -8 here for y equals a, -1 plus 3, -1 minus 1. So -8 equals a 2 times -2. So -8 equals a, do this multiplication, -4, divide both sides by -4. And so you get that a is +2. Okay, we can confirm this by looking at our parabola. When you go over 1, you're going up 2, which is consistent with an a value of 2. So we have our equation, y equals 2, x plus 3, x minus 1. Now, you could also write it as 2x minus 1, x plus 3. The order of these factors doesn't actually matter, but the 2 does need to be out front. Okay, now let's do question B, where we're just given information. So we have zeros of -3 and 1 and this vertex. So our R is equal to -3 and our S is equal to 1. So we have y equals a, x plus 3, x minus 1. So it's actually the same as our part A, but we'll have a different a value here. So now we have to sub in this coordinate. -5 equals a, -1 plus 3, -1 minus 1. So now we do brackets first, follow BEDMAS. So we have 2 times -2. So -5 equals a times -4. So a is equal to +5 over 4. Okay, notice that when you do -5 divided by -4, you get 5 over 4. And if it's not in a word problem, it's better to leave this as an improper fraction rather than changing it to a decimal. So your equation then would be y equals 5 over 4, bracket x plus 3, bracket x minus 1. Okay, guys, so that is your first note on the factored form of a quadratic relation. Thanks for watching. I hope you learned lots.